Every year, hundreds of millions of dollars worth of steam is needlessly wasted in the U.S. What's worse is a great deal of this money is lost by companies that are committed to energy management. Management dedicated the funds necessary for steam conservation. Engineering designed the return systems. The pipe fitters installed the traps and lines. And the accountants looked it all over and saw that it was good. At the end of all this good work, everyone turned away, went back to their business, and left the system to operate unattended for several years. Our message should come as no surprise. Everything in the world wears out, and steam traps are no exception. Some wear out much more slowly than others, but eventually they will all wear out. You can help put a stop to this needless waste by learning how to correctly inspect and repair the traps in your facility, and that is what this program is all about. We recommend that you begin by viewing 2 additional tapes from Armstrong. The first is called Let's Talk Steam Traps Update. This tape discusses the construction and operating principles of all the traps covered in this program. The second, Guidelines for Steam Trap Troubleshooting and Testing, will teach you the recommended methods for determining which traps in your facility need repair. Either tape may be previewed or purchased from your local Armstrong representative. The next step is to prepare and use a periodic maintenance schedule. Test high-pressure traps above 250 psi daily to weekly. Traps operating between 60 and 250 psi should be tested weekly to monthly. Lower pressure traps need to be checked at least once a year, more often if the trap is in a high-capacity application. Once you've located a faulty trap and disassembled it, you must be able to recognize whether or not the trap is wearing properly. Check to see that linkages are not bound. Wear on fulcrums, levers, and other moving parts that touch is most generally characterized by very shiny surfaces in the area of contact. Check guide pin holes to ensure that they are round, not elongated. A properly seating valve has a bright, narrow ring all the way around the circumference. A properly wearing seat has a sharp edge with no nicks or gaps. Grooving is a wear condition found on the valve. It is characterized by a deep groove in a continuous line around the entire valve diameter. Grooving is caused when the self-lapping action of the valve is allowed to continue over too long a period of time. Wire drawing is a type of erosion to both the valve and seat. It has the appearance of a scar made by someone pulling a wire back and forth across the surface. It is caused by a high-velocity steam leak across the seating surface over a long period of time. Armstrong supplies float and thermostatic traps with 2 different types of thermostatic bellows. Both should be open at room temperature. The Type A bellows can be checked for a rupture or misalignment of the bellows. The Type B bellows are sealed units which cannot be inspected. The valve and seat cannot be inspected in either of the 2 bellows types. The operating nature of thermostatic elements makes them rather fragile. If a trap containing a thermostatic element is malfunctioning, we recommend that the element be replaced. Check buckets for distortion or cracking. Inspect the top of the bucket for wear at the clip and along the rim for damage and leaks. If the bucket is weighted, make sure that the weight hasn't become loose or worn. Visually inspect floats for any signs of damage. Be sure there are no indications that the float has collapsed. Examine the float carefully for any sign of pinhole leaks, especially along seams. If the float has water in it, it is obviously bad. Sometimes, however, if the float has a leak near the bottom, it will blow itself out when the pressure drops in the trap. This makes the leak hard to detect. If you suspect such a leak, remove the float and immerse it in hot water. As the air in the float heats up, it expands and will bubble to the surface through any leaks that might exist in the float. Some traps are equipped with accessory items that also need inspection. If the trap has an integral strainer, the screen should be removed and cleaned. Worn or bent scrub wires should be replaced in IB traps that are fitted with them. If you have an IB that you have to disassemble repeatedly in order to clean a clogged bucket vent, you should add a scrub wire to the trap. If the trap has a vacuum breaker, check its operation by blowing air through it from the atmosphere side to confirm that it opens. Next, suck air in from the same side, which should close the valve tightly. If the vacuum breaker is worn or damaged, discard it and install a new one. Sometimes dirt can get caught in the vacuum breaker, causing it to operate improperly. If this is the case, adding a gooseneck to the top of the vacuum breaker can prevent it from happening again. There are a few more general rules that you should be familiar with before going into the field. Before opening any trap, make sure it is isolated from the system at both the inlet and the outlet by closing the appropriate valves. Then give the trap time to cool down before handling it. Once you have opened any trap, discard the old gasket no matter how it looks. Clean all the gasket seating surfaces. Before resealing the trap, remember to apply a new gasket. Generally, valves and seats are made and replaced as an assembly, and you should do so unless specifically informed otherwise. When replacing valve seats, examine the beveled surface at the bottom of the tapped hole, making certain it is perfectly clean. The joint is made by the metal-to-metal seal between that surface and the ground end of the seat. Therefore, do not use pipe dope or lubricant in the valve seat threads. With all that information covered, it's time to go to the shop, where we have a bench vise, a few simple tools, and Dan from Armstrong's Final Assembly Department, who knows these traps by heart and will demonstrate these procedures. Since the cast iron and steel IBs are our most popular models, we'll begin with them. No matter what type of testing program you follow, Armstrong recommends that all cast iron and steel IBs be opened once a year and their mechanisms inspected. Servicing an IB requires one more valuable tool, the IB Service Guide. This pocket-sized guide gives you information on trap installation, special precautions to take in freezing environments, trap options, and test and troubleshooting recommendations. A chart in the service guide correlates the maximum operating pressure for each of our traps to the various orifice sizes available. Finally, the IB Service Guide tells you how to identify and order parts for all Armstrong cast iron and steel IBs. When inspecting an IB trap, remember to isolate it from the line before removing the cap along with the operating mechanism. Discard the old gasket and clean all of the gasket surfaces on the body. In order to minimize downtime, we suggest that the cap and mechanism be replaced with a new or reconditioned spare. Be sure to check the stamp on the cap of the trap to make sure the working pressure of the replacement parts is equal to that stamped on the cap of the original. In some instances, the cap and mechanism may be replaced by another with a greater working pressure without harm, but this will result in a loss of capacity. At this time, it's also easy to assure yourself that the trap was installed correctly. Make sure that the flow direction arrows, that are cast in the body match the flow path of the system. Clean any accumulated sediment from the trap body and its cord passages. If the trap has an integral strainer, clean the screen. Inspect the inlet and outlet passages of the trap for corrosion. If corrosion is present, replace the trap. If not, install the replacement cap and mechanism, return the trap online, and take the worn parts back to the bench for repair. Clamp the cap in a vise and remove the bucket. Clean any dirt or scale from the bucket surface. Inspect the bucket. Check carefully at the top near the bucket clip and along the rim. Be sure that the vent hole is not clogged. If the bucket is damaged or worn, it must be replaced with a new one. Inspect the linkage, the valve, and the seat. Once a valve starts to seat improperly, it causes the lever and guide plate pins to wear rapidly, so they must be replaced at the same time. For this reason, Armstrong makes complete trap repair kits. These kits include all the necessary parts of the PCA, or pressure change assembly, a valve and seat set, lever, guide plate, and screws. The only other repair parts you will need are the gaskets. Here's a troubleshooting hint. If a trap has extensive grooving of the valve, shiny spots on the valve seat, bucket clip, and rim, and shows fulcrum wear, it might be losing its prime. The loss of prime may be due to pressure surges at the trap location. If the application suggests pressure surges, replace not only the PCA, but install a check valve in the trap. Clean the cap thoroughly and check it for erosion, as you did the body. Erosion occurs primarily where there is high velocity flow or a change in direction. IB traps are particularly susceptible to erosion in the channels in the cap and near the inlet and outlet connections of the body. Erosion is also likely around the valve seat if it is improperly seated. Castings that show signs of erosion must be replaced. Having removed all of the worn parts, we begin the repair work by installing the new PCA. Make sure that the orifice size of the new valve and seat are correct for the operating pressure of the trap. When installing the seat, remember to clean the beveled surface at the bottom of the tapped hole and to use no thread sealing compounds during assembly. Next, install the guide plate with the guide pins pointing toward the center of the trap. Hook the lever over the guide pins and press the valve firmly against the valve seat. The two fulcrum points should also rest against the valve seat. To check that the guide pins are centered in the guide pin holes, hold the valve against the seat while moving the bucket end of the lever from side to side. The valve end of the lever should move equally in each direction. If it does not, simply bend the guide pins until they are centered in the guide pin holes. The valve lever must still move freely from side to side. The purpose for this movement, or free play in the lever, is to allow the valve movement in the seat, providing a self-lapping effect as the valve cycles. Now hook the bucket onto the end of the lever, making certain that the open end of the bucket clip faces away from the valve. This completes the repair of the IB mechanism. The finished assembly can now be stored as a spare until it's needed. Like the IBs, the small cast iron A and B series float and thermostatic steam traps can generally be repaired without disconnecting any piping. Since these traps are similar, except for their size, we will use a B series F&T as an example for both. Close the inlet and outlet valves. Make sure the trap is cold and remove the cap with the operating mechanism attached. Discard the old gasket and clean the gasket surfaces. Then clean any dirt or sediment from the bottom of the trap's body, cap, and mechanism. Check that the trap body is free from erosion. especially near the inlet and outlet connections. Inspect the mechanism for signs of wear or damage. If any mechanical parts are damaged or worn, replace the damaged cap with a spare. To reassemble the trap, put a new gasket on the cap and secure it to the trap body using a cross-tightening pattern as you would when putting on a spare tire. Once all the bolts have been tightened securely, return the trap to service. Take the old cap and mechanism back to the bench for repair. Clamp the cap in a vise and check the linkage to see if it has been binding. Remove the lever by pulling the lever pin. Unscrew the float and inspect it. The guide plate is removed by unscrewing the seat. And finally, the thermostatic air vent can be removed by using a flattened wrench. Clean sediment from the cap and inspect it for erosion. We recommend that the Type B bellows be replaced each time the valve and seat are. Valves and seats must be replaced as a matched set. Be sure you have matched the new valve and seat orifice size to the operating pressure of the trap. Attach the valve to the valve lever and secure the guide plate by threading the valve seat through it. Do not use pipe dope or lubricant in the threads of the tapered seat fitting. Apply a drop of Loctite to the float screw and assemble the ball float to the valve lever. Attach the valve lever assembly by inserting the lever pin and check it for proper alignment. With the valve firmly seated, slide the lever pin back and forth to ensure it moves freely. If it does not, bend the ears on the guide plate in or out as needed until it does. The lever stop should keep the float from rising any higher than the inner diameter of the gasket surface. This prevents the float from hitting and wearing on the inside of the trap body. The rebuilt unit can now replace the spare you used to service the trap. Armstrong makes a number of stainless steel traps that are permanently sealed. These traps, the 1010, 1810, 2010, and TTF series, offer very long life and cannot be opened for inspection or repair. If, upon testing, you find the trap fails to close tightly, however, there is one maintenance operation you should perform. Dirt and scale lodged in the valve or mechanism may prevent the trap from tightly closing. To dislodge any foreign matter from the trap, force compressed air or cold water through the trap in the reverse direction. If the trap has a check valve in the inlet, hold it open with a screwdriver. When working on the thermostatic traps, remember that the bellows element is relatively fragile. Because of this, you must remember to avoid sudden pressure changes that will damage the element. Finally, we will go over the repair procedure of an Armstrong CD series disc trap. Rejuvenating one of these traps simply involves replacing the disc capsule. The CD60 series can be repaired without removing it from the piping. With the inlet and discharge valves closed and the trap cold, open the trap. Lift out the screen and remove the capsule. Discard the old gasket and clean the mating gasket surfaces. Install a new gasket and a new capsule. Place the cleaned or new strainer screen around the capsule and reassemble the trap and restore it to service. The Series CD40 must be removed from the piping for repair. To minimize downtime, install a good trap in its place while you take the worn trap to the bench for repair. Open the trap and clean the strainer screen if there is one. Remove the old disc capsule, clean the metal-to-metal seating surfaces, and install a new capsule. Reassemble the trap and restore it to service or place it in stock. Occasionally, a disc trap will malfunction because a piece of dirt or scale enters the trap and interferes with the action of the disc. For larger-sized disc traps, this problem can sometimes be corrected by taking the capsule apart and cleaning it out. When the obstruction has been removed, reassemble the trap and place it back online. Following a regularly scheduled maintenance plan can minimize downtime due to trap failure. Using these procedures, you can help save your company needless expense in wasted steam. All of the parts that you might require, as well as service bulletins, installation guides, technical reports, and videotapes, are available from your local Armstrong representative.